Hello everyone and welcome again to my How to Education channel. As I promised you yesterday, today we're gonna solve as many exercises as possible concerning the Introduction to Valuation, the Time Value of Money lecture. After watching this video, don't forget to leave me your feedback. Let's imagine that you have $25,000 today to invest for 10 years. How much would you have at the end of this time period if you were offered a 6% return? What about an 8% return? What would be the additional interest earned at 8%? Well, the present value is $25,000 in both cases, and the time is 10 years in both cases. R is either 6% at first or 8% later on. So the future value at 6% is equal to 25,000 times 1 plus 0.06 to the power 10, which is equal to 44,771. The future value at 8% equals to 25,000 times 1 plus 0.08 to the power 10, which is 53,973. To find the additional interest at 8%, we simply do the future value at 8% minus the future value at 6%, which is equal to $9,202. Your father plans to give you a $15,000 gift when you finish med school 3 years from now. Once you receive this amount, you intend to invest it at 10% compounded annually to receive $110,836. Calculate how much time you will have to wait starting from today. The answer is you will have to wait 3 years to get the gift, plus the time needed to make the $15,000 increase to $110,836. In order to find the time needed to make the money increase, we follow the formula time equals to ln future value over present value over ln 1 plus r, which is ln $110,836 over $15,000 divided by ln 1.1, which is 21 years. Thus, you will have to wait 21 plus 3, which is 24 years. If throughout 24 years, $5,000 became $20,000, find the annual rate given. The annual rate is R. Future value is $20,000, present value is $5,000, and T is 24. Therefore, $20,000 equals to $5,000 times 1 plus R to the power 24. By solving this equation, we get R to be 5.95%. Imagine that the $3,000 that you are going to receive now will only be yours 3 years from today. You decided that after this time elapses and you finally get the money, you will invest them at 10% compounded annually for 10 years. Calculate how much you will have 13 years from now. So, for the first 3 years, you won't have anything since you did not receive the money yet. When you receive it, you will have to invest it for 10 years. So the future value will be 3,000 times 1.1 to the power 10, which is 7,781. Thus, in 13 years, you will have 7,781. You have $1,000 and decide to deposit it at your local bank, which will pay you a 5% return rate. Your friend gives you another idea instead. You can invest $1,000 today and receive $1,300 in 4 years. What is the interest rate that your friend is offering, and which investment would be best for you. If you're gonna receive 1,300 in 40 years, 1,300 is your future value, 1,000 is your present value, and t is 4. Therefore, by solving this equation, you get r to be 6.78%. Nevertheless, in the local bank, you're gonna receive only 5% return. Since your friend is offering a higher interest rate, you should choose his investment. Today is your 20th birthday. You received $100 from your mother and decided to invest it at a 15% annual compounded interest rate so as to have $200. How old will you be when this goal is achieved? In this case, $200 will be your future value, $100 is your present value, and 0.15 is R. Therefore, 200 equals 100 times 1 plus 0.15 to the power t. By solving this equation, we get t to be 4.96 years. Since today is your 20th birthday, you will be almost 25 years old by the time your goal is achieved. Assume that you will retire 30 years from now. To guarantee that you will have a good amount of money by then, you decide to invest $1,000 at a 15% interest rate. Nevertheless, you're unsure if you should invest this amount now or 10 years from now. How much more money you will have in 30 years if you invest it now? The answer is, if you invest it now, you will have your money in 30 years. The future value would be 1,000 times 1 plus 0.15 to the power 30, which is 66,212. If you invested 10 years from now and you retire in 30 years, then your money will be invested for 20 years only. So the future value would be 1,000 times 1 plus 0.15 to the power 20, which is 16,367. 66,212 minus 16,367 is equal to 49,845. Thus, if you invested now, you will have $49,845 more than what you would have had you invested 10 years from today. If I invested money today and will receive $90,000 10 years from now, while you also invested today but will receive $90,000 only 12 years from now, what can we infer from this information if both of us invested money at a 5% interest compounded annually? The answer is, in both cases, the future value would be $90,000 and R will be 5%. In the first case, T will be 10, and in the second case, T will be 12. Since the time periods are different, then the present values of both investments will be different too. My investment will be worth more today than yours, since as T increases, present value decreases. If I deposited $3,000 today at a 10% interest rate for 10 years, and you would like to have the exact same amount as me by the end of 10 years, but at a 15% interest rate, how much less money do you need to deposit? So, if I deposited $3,000 today at a 10% interest rate for 10 years, I would have 3,000 times 1 plus 0.1 to the power 10, which is 7,781.23. I would have this much by the end of 10 years. If you would like to have the same amount by the end of the 10 years at a 15% interest rate, your present value today would equal to 7,781.23 over 1 plus 0.15 to the power 10, which is 1,923.4. Thus, you would only need to deposit $1,923.4 instead of the $3,000 that I deposited. 3,000 minus 1,923.4 is equal to 1,076.6. This is $1,076.6 less than what I needed to. Back in 1910, a competition took place and its winner was rewarded with $250. In 2010, that same competition took place, but this time its winner was rewarded with $50,000. If this event continues to take place every year, and the prices continue to grow at this rate, how much will the owner of the 2050 competition make? The answer is, from 1910 to 2010, 100 years have passed. The future value is $50,000 and the present value is $250. So $50,000 equals to 250 times 1 plus r to the power 100. By solving the equation, we get r to be 5.44%. If the price changes at this rate every year, then from 2010 to 2050, the future value would be 50,000 times 1 plus 0.0544 to the power 40, which is 416,089. Let's now go over some tips for solving certain questions. Number 1. If asked about how much additional money a person will receive or will have to invest, given two different interest rates or two different time periods, calculate the present value or future value using the first time period or the first interest rate. Then calculate the present value or future value using the second time period or second interest rate, and at the end, subtract the two numbers that you calculated. Number 2. Always remember that the future value when the interest rate is compounded will always be larger than the future value when the interest rate is simple. When they ask about how long it will take to double your money, instead of using the conventional way and setting the future value equals to 2 PV, you can use what we call Rule 72. This rule consists of dividing 72 by the compound interest. The answer you get will be the number of years needed to double your money. The most common example given about this rule is that it takes 9 years to double your money at a compounded 8% interest, and it takes 8 years to double your money at a compounded 9% interest, as in 72 divided by 8 is 9 and 72 divided by 9 is 8. Remember that we divide by the number and not by the percentage. That is, we divide by 8 or 9 and not by 0.08 or 0.09. To see how long it takes to multiply your money by 4, divide 144 by the compound interest. This is Rule 144. Always remember that since interest is involved, future value is always larger than present value. If interest is 0%, then future value equals present value. When talking about simple and compound interest, remember that simple interest is applied only on the original amount, and compound interest is applied on the original and on each of the reinvested amounts, thus increasing the interest received every year. future value equals present value times 1 plus r to the power t. Thus, if t increases or r increases, future value will increase, assuming that present value is kept constant. Present value equals future value over 1 plus r to the power t. Thus, if t increases or r increases, present value will decrease, assuming that the future value is kept constant. The future value formula shows how large the amount you deposited can get and how beneficial it would be to start saving money early on in your life, so as to guarantee an adequate amount of money for your retirement. This is it from finance for this week, but if you have reached the end of this video, it is because the content was helpful to you somehow. If this is the case, then please give your friends and acquaintances the opportunity to have access to these videos by liking, sharing, commenting, and subscribing. We will be continuing with more finance next week, but before that, I will see you all on Friday or Saturday with some economics content. Thank you so much.